Thank you, experts in the dais and the delegates for this conference. I'm extremely happy to be here at this session where we are discussing on emerging technologies which are being pursued by the government of Kerala right now. This particular presentation on microgrids had been presented at the Chicago annual conference of IEEE International Electronic Society a few days back. I just made a few modifications to that presentation and brought it here. Basically, the relevance of this is essentially as a part of the Sustainable Development Goals, Kerala had picked up a target of, at the national level, the target for greening and for making India carbon neutral is 2070. But Kerala, given the precarious condition of climate adaptation, has made a more aggressive target of 2050. And it's in this context that various options for energy efficiency are being looked at. And we will see later that the high-rise buildings consume quite a lot of energy, and it's a major sector where we have to address. And it is in this context that we had built up the first public building in the state with 48-volt DC. 48-volt DC is a new standard for low-voltage DC, which has government of India has come up. There is also an equivalent standard for high-voltage DC for 384 volts. We have tried it out with the 48 volts, and we have also retrofitted our existing building as a green building. We are yet to get the IGBC certification. We are working for it. It's not very easy for a retrofit building to get an IGBC certification. We are likely to get it soon. So there's the context. We have moved towards a 48-volt DC system and a green building context. This is the building, the five-storied building that we have. We have used a variety of passive features as well as active features to see how the energy consumption can be substantively reduced. Now, I might not go into the entire details of the consumption and other details. 78.29% of the connected load is for air conditioning, and 8.5% is for lighting, and the energy consumption peaked at 5,278. And then into the power quality analysis, we had quite a lot of harmonics. The harmonics stood at 29.28%, with the third harmonic at 28.44, exceeding the permissible limit of 7%. So I would go to explaining what are the features that we have introduced. As I told you, we have brought in the 48-volt DC. The concept of a 48-volt DC, in fact, one of the first end-use energy consumption for the whole of Kerala was done along with Indian Institute of Science by me in 1992. And that indicated that the major load for domestic and commercial sector is basically lighting and ventilation. And air conditioning was not a very important load, but over the last 20, 30 years, the consumption pattern has drastically increased with the air conditioning load growing substantively. And this is the reason why, and also the computing load or the equipment load becoming very important. And the concept what we are trying to look at here is basically to use rooftop solar. If you are using rooftop solar, there is no necessity for converting the direct current which we generate from the solar panel to AC and then convert it into DC again and then use it in the various devices. So that is the logic for going for the 48-volt DC. Now, apart from that, in our building, we used a vertical axis turbine, 1 kilowatt. It's not very effective as of now. There are challenges with the design and things, but anyway, it has come in as a sort of an additionality. Then we have also created a water curtain. You have seen the facade of the building with a huge glass wall. So this has come up as a sort of a mechanism for cooling, reducing the heating, the air conditioning load inside. Then the southern side of the building, we have got double glazed walls, which have also, 10 number of double glazed walls have been added, which have also effectively reduced the air conditioning load inside the building. In fact, we couldn't get DC air conditioners. An air conditioner has basically a fan and a compressor. So naturally, moving towards a DC air conditioner is very easy. But at the time of doing the retrofitting, our contractors refused to use the Chinese devices, saying that they will not be in a position to provide warranty. We had not enough suppliers for the sort of air conditioners which at that point of time. But for my new project, which I am going to start in Kottarakara for the Vernier home, where I am going to use some of the techniques again, I am fortunate to have a lot of options for air conditioners as well. We also used an aero water maker, which was basically a startup product which produced water from atmospheric humid air, which used a Josephson junction. And this is from Sri Krishnapuram Engineering College. So this is the top of the building. We have, around 20 kilowatt of electricity that we generate. We use a mono PERC 450 watt solar panel, which has the half cut, which has the highest efficiency, possible highest efficiency, much better than the polycrystalline sort of solar panels which are available. And we have also used a 1 kilowatt vertical axis turbine. There is option for 2 of them, but this turbine is not very effectively functioning, and the sort of at the sort of wind speeds that are available. We had been trying to address the phenomenon of what we call thermal islanding, which is becoming very important in urban centers, especially on high-rise buildings. So that is the logic why we had looked for the vertical axis turbine. Again, it is also provided with an MPPT to vary the pitch and also the rotation speed for maximum power transfer. This is the microgrid that we have implemented with the wind generator and solar power generator in the particular building, which we have implemented basically with a battery bank of lithium iron phosphate on each floor. We have put the lithium iron phosphate batteries, and we have put the and now for all the computing load we have provided DC-DC converters. We couldn't use for the networking devices because the Cisco devices which had don't come with DC conversion support. But now we have put an R&D team to see how we can. Nothing so great. You have to use a DC connector and then connect it to the point where you connect the SMPS. So we are now trying to work on the networking devices. So basically the issue that we are facing is that the supply chain is not tuned to this sort of conversion. There's a huge possibility for moving over to 48 volt DC and things, but the industry has not coped up to this opportunity. I wanted to have sensors for occupancy sensors, but they are not available. They are only available at higher voltages. It's a simple student project which can be commissioned. In fact, we are doing that as a part of a student project to see whether we could have occupancy sensors made. So this is a sort of microgrid system that we have built. This is the water curtain that we have put. These are the double glazed windows that we have provided. Now, overall, coming to the total numbers, I've been able to reduce the energy consumption figures. If you look at, there is a saving of 8,221.21 kilowatt hour is the sort of overall saving that I am getting, which is almost like 1/10 of the total existing load. And I have added up another 32,230 because I wanted to have an electric vehicle charging station. That's a new requirement which has come up. So I have put up an EV charging station. I also put up a fairly big display window for displaying information at the front of my building. So all these have added additional load. 23.95 kilowatt has been added. I am in a position to save this. I have put a behind the grid meter system for the solar power, and I am in a position to push the additional power. In spite of the low tariff, I am in a position to have a break-even by 9 years. That is the sort of thing. In this existing retrofit building, it's a fairly high-cost model. I have put complete backup for the lithium iron phosphate batteries. They are fairly costly. And even with this, I am in a position to have a complete break-even in the 9th year. I am trying to try out a similar system for the Kottarakara, the first Vernier home building which is going to come up at Kottarakara, where we are going to have a biophilic design. And because in the co-working space, people are going to be there for 280, 300 days. I mean, if you look at the overall year, bulk of the time, the children are going to be, the youngsters are going to work in that space. So thermal comfort and wellness is a very important factor. So we are going to integrate a biophilic design. I'm going to try out a high voltage DC system. And I'm trying to improve the high voltage AC system with quite a lot of passive features and liquid disk and cooling also. And again, solar and wind options are being used, and entire lighting, ventilation, and air conditioning inside the building, and also the computing load will be based on DC. This is what we are trying. Actually, Thomas Alva Edison had come up with the DC distribution model, which was rejected just because Tesla came up with a brilliant model of the transformer which was suitable for transmission and distribution. It was ahead of the times, and the DC distribution model was rejected. That was one of the greatest failures of the innovator Thomas Alva Edison. But now it is time and an option for using DC and solar, and that is what I'm trying to do as a part of the microgrid. This is how the microgrid as a technology has evolved. It has basically evolved from decentralized power, renewable energy integration, smart grid initiatives, the military defense applications where you have to move to the field and then use power, rural electrification, energy storage options. In Kerala, there are limited possibilities because there is no economic driver, because there is only one DISCOM. Peer trading is not there, and competition is not relevant. But still, there is a possibility for working on grid stability, reliability, energy storage, and arbitrage. I had talked about only the carbon neutral aspect and the savings, the energy savings aspects only. In terms of the peak power, I am saving at least 10%. I mean, I will be contributing to reduction in the peak power and also improving the reliability of the grid. Why this becomes important is that Kerala has projected 4,500 megawatt peak by 2025, 1,000 megawatt solar, and 10% energy demand growth annually. And this becomes extremely important. If I look at the high-rise buildings, there is a study on high-rise buildings and their energy consumption. The total energy consumption of Kerala, 20% of that comes from high-rise building. The average consumption is 1.5 million kilowatt hour. My building is not a high-rise building. A high-rise building is a 10-floor storied building. My building is only a 5-storied building. But I am trying to put 3 such buildings together as a cluster to implement it equivalent to a high-rise building. This can reduce consumption of up to 30%. Up to 30% of this, which would mean 6% of the total energy consumption. What I am trying to do is, I have done it for one of the buildings, the KDIS headquarters. I am trying to link 2 other buildings together as a microgrid and take this forward. This is something which has been done in practice and holds quite a lot of promise for